What is going on, guys? Welcome back. In this video today we're going to build a professional real estate scouting tool in Python. So let us get right into it. Alright, so let us take a look at the real estate scouting tool that we're going to build in this video today. This is the final result. Here we have Austin, Texas, and as you can see, I can zoom in here and look at a bunch of different properties. So I can zoom in closer and then I can click on individual properties to get some information like the address, the price, the number of bedrooms if present, bathrooms, living area, gross rental yield, the Zillow estimate, so how much the property is worth according to the estimate of Zillow, how much the rent is estimated to be by Zillow, and then we also have a link to the actual property if we want to take a closer look. And I can also show the price history if present. So what this application does is it tries to get the price history. If it does not exist, it's going to give me a no historic data, which is oftentimes the case. But sometimes I will get some information, a table that displays the price history of the property, which can also be interesting for investment decisions. And as you can see, a lot of these properties here have a black color, which means that they're off market. But some of them, for example, are not. This one here is red. The color is determined by the gross rental yield, so how much the rent is in relation to the property value, to the estimated property value. In this case here, it's worse, so it's just 4.66%. Here we have an orange one, which has 6.39%. And then maybe we can also find some green ones which have a higher yield. But that is the basic tool that we're going to build in this video today. We're going to work with a lot of data. We're going to look at properties. We're going to be able to find properties like this. And of course, you can customize this. You don't have to build the exact same tool that I'm building here. You can also change a couple of things. I'm going to tell you where and when you can change certain things to adjust it to your preferences and your needs. But this is what we're going to build in this video today. Alright, now in order to make this an actually useful real estate scouting tool, we need to make sure that we have a lot of data, we need to make sure that we have data which is up to date, and we need to make sure that we have access to some endpoint that can give us information about the price history if it exists on demand for specific properties. Now, of course, you can build a prototype of this with a small data set just to play around with, but if you actually want to make this a useful tool, you need to have a lot of data, up-to-date data, and you need to have this access to an API or an endpoint that gives you also historical information. This is why I partnered up with Bright Data for this video today. They're offering exactly that. For those of you who don't know Bright Data, they are an all-in-one platform for proxies and web scrapers and data sets and so on. So if you go into their control panel, once you create an account, you will see they have proxies, they have web scraper APIs, and they have data sets which we can use here, which are up to date and can be filtered on their platform. And this is what we're going to do in this video today. So we're going to use the data set from Bright Data, the Zillow data set, and we're going to filter it to be only Austin, Texas, the last couple of days. And then we're also going to use their web scraper API to make requests about historical price information if it exists for the specific property. Again, as I said, you can start by building a prototype with a small sample. You can also get a sample from Bright Data from their data sets for free. But if you want to build this into a useful tool that you actually use for real estate scouting, it makes sense to have a lot of data. It makes sense to have up-to-date data and also an access to an API that gives you historical information. So what we're going to do first is we're going to create an account on Bright Data. I'm sure you can do this on your own, so I'm not going to show you how to do that. And probably you have to set up some billing and some payment here if you want to use the actual data set. But as I said, you can also get a free sample. So what we're going to do is we're going to go to web data. We're going to go to the Zillow data set. So just look up Zillow or just click on Zillow if you see it right away. And what you can do then is you can get a sample. So you can download a sample for free as a CSV file if you just want to have the structure. So you can build the exact project here using a sample if you don't want to start by purchasing some data right away. And what you can do here in general is you can go to all records, you can click on filter, and then you can say, I'm only interested in a specific subset. So I can say, I can click here, I can say my fancy subset, and then I can say, okay, what am I actually interested in? For example, I could be interested in city is equal to, and then I can say I'm only interested in New York, or actually let's say something like San Francisco, like this. And then I can say I'm also only interested if, for example, the number of bedrooms is lower than 4. for example. Now you can do whatever you want, but basically when you create that filter, it's going to show you how large the data set is. So it's going to tell you that with this configuration, you're going to get this amount of entries, and then you can calculate how many gigabytes that is, and you can see if that's too much or if that's too little. But basically, the idea here is you can filter a data set the way you want on this platform, and then you can download the subset and purchase the subset if you want to. But again, for the sake of this video, you can start by just downloading the free sample to work with. And what I did for this video is I filtered for Texas, for Austin, Texas. So my data is Austin, Texas of the last 5 days when I downloaded the data set. But the basic idea is you either download the sample or you purchase the data set. When you purchase the data set, you're going to see it in My Datasets, and you're going to see that the sample is ready to download. So you just go to the snapshot here, like this one, and you can just download it as a CSV file. This is basically what I did. You can see in this case here, my snapshot, which is Austin, Texas of a 5-day span, has 2.24 gigabytes, which is manageable. If you have a large data set, you can also export it to AWS or to Amazon S3 or to other storage providers. So there are a lot of options to get the data. In this case here, I chose a small sample and I downloaded it as a CSV file so that I can work with it locally. So that's the first step. This is what I already have. What you also want to do then later on for the API request is you want to go to account settings, you want to go to user access, and you want to create an API token here so that you can use it for the API. But we're going to talk about this later on, or actually I can show you how to do that right away. So you go to Web Scraper API, you go to Zillow. So let's look up Zillow here. And in this case here, I went for price history. The basic idea here is you provide a URL of a property, which you also see in the dataset. And then what you do is you make an API call for that URL and you get the historic price information. You get the historic price information if it's present. So you can see how this is done. You can say, for example, I want the data as JSON input. So you just provide a couple of URLs. And then here in this case, now it's written as a curl request, but we're going to do that in Python. So we're going to change the way this is done in Python, or we're going to do it in the same way, but we're going to use Python instead of curl. And the basic idea is we authorize ourselves with our API token, which we created, and then we just pass a list of URLs. And as a result, we're going to get a snapshot ID. And this snapshot ID, then we can use another curl request for, or request in general for, to download the snapshot as a CSV file, for example. I can specify CSV here. We're going to do all of this in Python, and we're going to model all of this as a Flask application. So let us get started with this. I'm going to start by creating a file called app.py, which is going to be our Flask application. Now for this video today, we're going to need a couple of packages. So open up your command line and install the following packages if you want to build this as well. And again, as I said, you can work with a free sample. You can do the same thing that I do here with the free sample. It's just going to be less data and probably not exactly the data that you want, but you can do all of this with the free sample. I think just the API request is not going to work. But you can follow along like this as well. So pip or pip3 install, Folium for the map visualization, NumPy and pandas to work with the data, requests to make the requests, and Flask to build the web application. So these are the imports. Make sure you have these packages installed, and then we can get started by importing a couple of core Python packages. Import OS, import JSON, import time, import, or actually from functools, I'm going to also import cache. Now, why do I import all these things? Let me briefly explain that. JSON to work with the JSON objects, with certain dictionary type objects in the data. OS to see if certain files exist. Time in order to wait to do certain things, because when we create the snapshot, we cannot download it right away. We need to wait for 5 seconds to try to get it. Maybe we get the message that the snapshot is not ready yet, so we wait maybe for 10 seconds to load it again. Instead of crashing the script, we can wait, so we use time for that. And we use cache in order to not have to make the same request for the price history all over again, because otherwise if I click on request the price history, then I get it, then I click away, I would have to do it again. So in this way I can just use the cached response. So this is why we need these core Python packages here. We're going to use, of course, requests to send the request that we saw in curl in Python. And we're going to use NumPy and pandas to work with the data sets. So import pandas as PD and NumPy as NP. We're going to use Folium for the map visualization. So from Folium.plugins, we're going to use the marker cluster class, and from Folium, we're going to also use the macro element. Now, I'm not actually sure if I need all of these, so maybe we're going to also delete them because I don't use them, because I played around with creating the map and maybe we don't use this one anymore, but I'm going to see if that's the case later on. And then we of course also need to import Flask. So we need to say from Flask import Flask for the application. We're going to import render template, and we're going to import request. So these are the imports for our application here. And now we can start by saying the application is Flask __name __. By the way, what you see here already is I have the dataset as a CSV file here. So this is Zillow _AustinTX. This is basically the CSV file I get from Bright Data when I choose my subset and I download the snapshot. This is what I get. In your case, this could be either your snapshot or the sample that you downloaded. And I also have a file token, which just contains my API token. Now, what we're going to do here is at the beginning of the application, and this will take some time, we're going to load the dataset. Now, what you can also do here is you can also explore the dataset if you want to. So what I can do, for example, is I can go into my directory. I can start here with Jupyter Lab. If you want to do that before you get into coding, you can do that. So we can just create a notebook here. Let's call it main, and explore the data. So we can say import pandas as PD. And then I can say data frame equals PD read CSV and then Zillow AustinTX CSV. Because if you don't know what the data is about, of course, you need to first look at the columns, at the data types, at the different things that we can work with, because we do have a lot of features in this data. The data set is quite comprehensive, which is of course good, but we also need to know what is it that we actually need from this data set. So if I look at the data frame here, I do have this irrelevant unnamed column, and I have then also the ZP ID. This is important. This is a unique identifier for a property. So I think this stands for, I guess it stands for Zillow property ID. I'm not sure about this. Then also city and state, obviously Austin, Texas here. And then we also have stuff like the home status, address, which is going to be important specifically here. This is why we need the JSON package. We do have a dictionary here with multiple information or multiple fields here. We want to have the street address. And then we have stuff like bedrooms, bathrooms, and so on. Now, I'm not going to do the dataset exploration here because this would just take too long to look at everything. I want to get into coding here, but it makes sense to maybe list the different columns that we have and to discuss which ones we're going to use. I'm going to briefly summarize it for you. So as you can see, we have a bunch of columns here, a lot of them, and we're not going to look at all of them. In particular, we're going to need the identifier for identifying specific properties when we want to get the price history. We're going to look at the address to get the street address. We're going to look at the price, and we're going to specifically look at also the Z estimate and rent Z estimate. These are basically Zillow estimates. This is the property value estimation, and this is the rent estimation. So how much the property is most likely to be worth and how much the rent is most likely going to be. Now, the problem with the price is that sometimes it's the rent and sometimes it's the property value, so we cannot use it always. Because of that, we're going to use the estimates here. So this is always the property value and this is always the rent. Also, of course, we're going to need to have the longitude and latitude, the coordinates, to make the visualization possible. And we're also going to use, or actually, are we going to use anything else? We're going to use for the markers, obviously bedrooms and bathrooms, so that we have some information to display there. But besides that, we're going to craft our own features. For example, the gross rental yield is going to be just the it's just going to be the annual rent divided by how much we think it's worth, and the annual rent is going to be just the rent estimate times 12. So we're going to craft our own features here for the visualization. But of course, as I said in the beginning, you can customize this to be whatever you want. Maybe you want the color of the markers to be dependent on the number of bedrooms, or maybe you want to have it depend on something regarding to taxes. There are a lot of features in here, and you can work with them whatever way you like. I'm going to show you one example or for how you can craft this tool, but you can of course adjust this to be whatever you want. You can have it completely customized. You just have to use different features, different ranges, and so on. But as I said, we're going to use the property ID, the address, the bedrooms, the bathrooms, the price, the longitude, latitude, and also the estimates here. So that's basically it. All right, so I'm going to start by loading the data frame into the application. We're going to say pd read CSV, and we're going to load the Zillow Austin tx.csv file. And then our application is basically only going to have two endpoints. Now, you could structure this in a different way if you want to, but my idea here is to have an index endpoint, which I can just, where I can just look at the map, and another endpoint where I can ask for price history. Now, our index endpoint will behave differently depending on whether we already have a map or not. So the first time we run this, it's going to take quite some time to create the map. But then once the map is created, we can basically just load it immediately. Even though it would probably make sense to have some update algorithm. In this case here, I'm just gonna say that once we have the map, we're going to keep the map. But of course, if you change the data set, if you, for example, get another snapshot from Bright Data, it makes sense to also reload the map. So to also delete the map. But let's get started. We are going to say here app.route is going to be the /route. This is going to be the index function here. And we're going to say here if, this is why we need the OS package, if os.path.exists. And now we're going to look for the following path. We want to know if templates / property map.html exists. Now this is going to be our map in the end. This is going to be what we craft with Folium. But if we don't have it, we want to create it. Otherwise, we just want to load it. So if it does not exist, or if it does exist, we're going to say return render template and then just property map HTML. The reason we don't provide templates here is because templates is the default template directory of Flask. If you want to change that, you can say template folder equals something else, but by default it's templates. So if you provide property map HTML, it's just automatically going to look for templates property map HTML. So if it exists, just load it, just return it. Otherwise, we need to go through the process of creating it. And this is going to be quite comprehensive. So we're going to write a lot of code here for a single video, but we're going to start by first of all dropping all the nan values or all the rows where we have nan values, so not present values for the coordinates, because we don't want to visualize any property that we don't know where it's at. So we only want to visualize the properties that we can actually put on the map with coordinates. So we're going to say here data frame is equal to data frame drop NA, so drop the nan values, considering the subset of longitude and latitude. Now, what's the problem here? Actually, this should actually work. I mean, it does work, so I'm not sure why it doesn't think it works. Maybe we can do global df. I think this shouldn't make a difference. I think it also works if we don't do that, but let's just do it. So we're going to drop the nan values, or we're going to drop the rows that have nan values for the coordinates, and then we're going to craft a couple of features. Now, first of all, we need to make sure that the features rent estimate or rent z estimate and also the normal estimate and also the price are actually numeric. So we're going to say here data frame rent z estimate is going to be equal to pd to numeric df rent z estimate. And we're going to say errors is equal to coerce. And now I'm going to do the same thing now for the z estimate and for the price. Obviously here we need to change this as well. And then we have these features as numerical features. Now, based on these features, we're going to now craft additional features. We're going to say that the annual rent is going to be equal to basically the rent estimate times 12. So df rent z estimate times 12, because the rent estimate is per month, so times 12 for 12 months is going to give us the annual rent. And now the gross rental yield is just going to be the annual rent divided by the property value, the estimated property value. The reason we don't do it with price is, you can also do it with price if you want to, but the problem is that price is sometimes also rent. So the easy way here is to just go and use the z estimate. So I'm going to say here, the gross rental yield is going to be equal to taking the annual rent, dividing it by the z estimate, and taking that times 100. And this will give us a number like 6 point something, 4 point something, just the gross rental yield. Now, what we also want to do now, this might lead to some divisions by 0 or something. Because of that, we want to replace infinite values with nan values. So I'm going to say here, gross rental yield is going to be equal to gross rental yield. And we're going to call replace on the following list, np_inf and np, or negative np_inf. Will be replaced by np_nan. So we want to have nan values there if the value is infinite, because otherwise we can have some bad coloring. We don't want that. So we're just going to say if it's nan, we're going to have a special color for it. And this brings us to the next function. Now the color of our markers, so of the individual property buttons that we can click, is going to be determined in this example here by the gross rental yield. Now, again, this is a place where you can customize it the way you want to. Maybe you want to say the color should be dependent on something else. If you want, for example, to make the color dependent on the z estimate, you can do that. Just make sure you have reasonable thresholds, because what I'm going to do here now is I'm going to say define a method or a function, get marker color. And this get marker color will get two arguments. First of all, the gross yield. And second of all, whether the property is off market. Now, this is a feature of the dataset. I think I forgot to mention this. There should be a feature somewhere here called is off market. I'm not sure if we're going to find it now. There you go, is off market. And this tells us if the property is off market or not. So if we can buy it or not. And if it's off market, I want to have a special color. Now, maybe you don't want to have that. So maybe you want to consider the gross yield regardless of if the property is off market or not. Maybe you want to contact the owners and say, hey, do you want to sell it? But I'm going to say if the property is off market, I'm going to return the color black. Now, otherwise, if the property gross yield is nan, so PD is NA, gross yield, then what I want to do is I want to return gray. And in all the other cases, I'm going to focus on the value. So for example, if the yield is less than 5, so less than 5%, I'm going to return red. If the yield is less than 8, but not less than 5, then I'm going to return orange. And otherwise, I'm going to return green. So if it's above 8%. Now, whether these values make sense or not, you need to define it. I'm not a real estate agent. I'm not a real estate expert. You will set this up the way you want to. So you will set your own thresholds, your own criteria. The basic idea is you get a function, you pass some of the features into that function, and then you return a color depending on your analysis. You can have your own complex logic here, comparing 50 different features and 100 different cases, and then returning 100 different colors. That's up to you, but this is the basic idea. We have a function get marker color that we pass information to, and this function will give us then the color of the individual markers. So now we get to the map visualization. The map visualization starts with us centering the map at a certain position. For this, I'm going to define a map center, which is going to be a list, and this is going to be a list of 2 coordinates. Very simple. We're going to take the latitude. We're going to take the mean. This is going to be our latitude, and we're going to take the longitude. And this is also going to be the mean here. So we just center at the mean position of all the data points. We could also go with a median if we want to. Maybe if you have multiple states, a median might be more reasonable, but we're going to go with a mean here. All right, then we create our map. M is going to be equal to folium.map, and we're going to pass here the location we want to focus on is the map center, and we want to start with a zoom level of 12. Again, this is also something that you can adjust depending on how far you want to zoom out. If you have multiple states and multiple cities, it might make sense to decrease this number. And then we're going to create our marker cluster. This is going to be the collection of our markers. This is going to be a marker cluster object, and we're going to add this marker cluster to M, to our map. And now we're going to go through the individual data points of our data set, and we're going to create the various markers. So I'm going to say for index and row in data frame iteros. So I'm going to iterate over the rows, and I'm going to get the information that I need. I'm going to say price is equal to df price. And this is now basically the same thing that I'm going to do here. So I'm going to have the price, I'm going to have the address, I'm going to have the bedrooms, and I'm going to have the bathrooms, and I'm going to have the living area. This is also one of the features that we're going to use here, living area. And we're going to use the gross yield, which we calculated. These are now all the informations, or this is all the information that we're going to display in the pop-ups as text. So this doesn't have to be related to styling. But when we click on a button, we want to see this information. Again, here, feel free to include all the information that you need. So gross yield is going to be, of course, gross rental yield. Then we're going to say that the z estimate is equal to the z estimate, and then we want to have rent z estimate is going to be equal to rent z estimate. And finally, we also want to have the property URL so that we can have a link to the property and the ID. So df zp ID, which I think again stands for Zillow property ID. This is a unique identifier. So this is what you can use to identify the same property across multiple data sets if they are Zillow data sets. All right, so we're going to say now if PD is an A, if we don't have a price, we need to make sure that the price formatted, or actually we're going to do it the other way around. If not is an A, we're going to format the price a certain way. So we're going to say we want to have a dollar symbol, and then we want to have price with 2 decimal places. Otherwise, we're just going to say that the price is missing. So the price formatted is going to be equal to the string n/a. And we're going to do a very similar thing now for the z estimate. So we're going to say here z estimate, and we're going to say here z estimate like this. And here as well, z estimate, and here we're going to change this to z estimate. Now, of course, we don't want to have this as a string. This is a mistake. We want to have the field that we got, so the series object. So we're checking if this is nan, or if this is a not existent value or an invalid value, if this is an invalid value, and we also want to do the same thing for the rent and also for the gross yield. So we want to make sure that the numbers that we're displaying are either NA, I think this stands for not available usually. So we want to display this if they're not existent, and otherwise we want to display them properly. So rent z estimate, rent z estimate, and rent z estimate. And finally, the last one is the gross rental yield. So I'm going to say here gross yield is what I called it, I think. Gross yield formatted, gross yield, and gross yield formatted. All right, so that should be it. So the numerical values that we're interested in, they are either an A or not. And actually, we can also do the same thing as a one-liner here. Since we don't need to really format them, is we can say bedrooms is going to be equal to int bedrooms if not PD is NA bedrooms, else we can just say NA. Now we can copy the same thing for bathrooms. Yeah, and for living area. There you go. All right, so I think that should be it. And now what we're going to do is now we're going to get into the HTML stuff. So what we want to have is we want to have a div box basically, which, let me just see if that makes sense. I need to double check with my prepared code. No, actually we don't need this anymore because I had a different approach when I was preparing the video. But the basic idea now is we're going to get the street address from the address, because remember the address, do I have it still opened up here? The address is a dictionary object and we want to get this street address field here for the pop-up. So we're going to do that, and then we're going to create the pop-up text, and the pop-up text will be HTML code, and we're going to also add JavaScript code in there, because in this pop-up we want to have a button that requests the price information from our Flask application and from the web scraper API. So we need to actually have some functionality in there as well. So we're going to do that. But let's get started here with the address. So the address is going to be equal, or the address dictionary, let's call it, is going to be equal to JSON load string. So load S, not JSON load, load S. And here we pass now the address text that we loaded from here. And we're going to say now that the street address is going to be equal to address dict street address. Now I'm not sure actually if this is stupid that I'm doing it like this, because there is actually a field street address, so chances are that we have this information here already. You can try out. I'm not gonna experiment now because this works for me, but chances are you can just get this value using the street address column. And now we're going to design the pop-up text. So pop-up underscore text is going to be here a multi-line string, and we're going to have a bunch of fields here. We're going to have B for bold. This is now just styling. So this is going to be in bold text. We're going to say address, and we're going to have the, and this needs to be a formatted string, so an F string. We're going to have the street address here. And then we want to have a line break. And like this, we're going to now add all the different fields. So we're going to have price, bedrooms, and so on. Bathrooms. What else did we have? Living area. We had gross rental yields. We had the Z estimate and the rent Z estimate. And now we also replace all of this here. Bedrooms, bathrooms, living area, gross yield, and, or actually, we need to use the formatted ones. Okay, so we need to use the price formatted. Bedrooms, bathrooms, living area works like this. Then for gross yield, we want to use formatted as well. Then here we want to use Z estimate formatted and rent Z estimate formatted. And we also want to have now an A tag here that goes to the following location, row URL. Or actually, I think I actually got this as property URL. So we're going to say property URL here. Now the important thing is that we say target equals underscore blank. Why? Because we want to open this in a new tab. We don't want to open this in the iframe, which is the pop-up. So the pop-up is an iframe. I don't want to click on the pop-up and then be redirected to the property in the pop-up. I want to open this in a new tab, which is why we use this target blank. And here now I'm going to say Zillow link and another line break. And then finally we have our button. The button will have the ID button dash index. This is important because the index is here from the iteros to have a unique identifier. Even though I'm not entirely sure, I'm not 100% certain that this even matters because we have these different iframes. I don't know if they have conflicting, if they even relate to one another in the HTML code. I'm not sure about this. But yeah, we're going to go with button index here, and we're going to say on click, we want to on click, we want to execute the following function. Show loading and redirect is what I call it. And we're going to pass here index and the Zillow property ID, ZPID, as a string. So we add quotations, single quotations around this, not around the index, but around the ZPID. And then we say show price history. Now, what is the idea behind this? What are we trying to do here? The basic idea is when I click the button, I want to use JavaScript code to show a loading animation, but I also want to use the JavaScript code to send a request, or actually not to send a request, to redirect to the API call. So to actually get, to actually go to the page, because the idea here is not to get the information from the endpoint and to then display it like a JavaScript request. The idea is to redirect the iframe, which is the pop-up window, to a Flask endpoint, which renders an HTML file and shows the table with the price history. So we actually want to go there. We don't want to actually make a request. We want to go there, which is why I call this redirect. So we show the price history like this, and then we go and say we want to have div ID equals loading. I need to use double quotations here. Loading dash index again. Again, not sure if this actually makes a difference, but we're going to set the style. This is important now. Equal to actually, I didn't close this. Style is equal to display none. And in this div box here, we're going to say that we want to have an image. And the image source, and this is now I got something from Wikipedia. I'm actually going to copy this. I don't want to type this out. So I'm going to copy this from my prepared code. This is actually a loading animation GIF. So you can also use any other GIF, but this is just a circle rotating. Got it from Wikimedia, so from the Wikipedia Commons. And then basically I say alternative text is loading. And the width is going to be equal to 50. Now, this is not blocking my camera, right? Okay. And the height is also going to be equal to 50. So that's just an image tag showing a loading animation. It doesn't show it in the beginning. The idea is to click the button, and the function that we're calling here will display this and hide the button, which is why we need the IDs. We need to hide the button, show the div box, and then we want to be redirected once once the response works. So we're going to say script, and this script is going to be a JavaScript script. I don't think that we need to specify this necessarily, so let's see if it works like this. But what we're going to do here is we're going to define the function show loading and redirect. We're going to pass the index and the ZPID. And we're going to say here using 2 curly brackets. The reason we want to use 2 curly brackets and not 1 is because otherwise this is going to be considered like this here to be Python code. So we want to use 2 to make sure that this is actually a JavaScript curly bracket. And then we're going to say document get element by ID. And by the way, really, I don't really enjoy coding in JavaScript, CSS, HTML. So this is very, very basic core JavaScript code. Those of you who know how to code JavaScript well, who know how to use jQuery well, do it the way you want. This is just me coding a basic pop-up with some information, a button, and a link. You can also be creative here and add some more stuff. But we want to get the button with the index. So I'm going to say IDX here. We're going to get the style of this element and set it to none. So we want to remove the button, basically. And we want to do the opposite for the loading index. Here we want to set display to visible, or actually to block. And then we want to say window.location.href. So we want to change the location of the current window to the following. And now I'm going to use http://localhost port 5000/price_history. Now, why do I do that? I'm going to explain this here in a second, but we want to add to this also the ZPID as a string. The reason I do this is because the application that I'm running here will run on localhost port 5000. If you change that, if you run it on some other port, or if you run it separately somewhere else, you need to adjust this to be the actual Flask application and the actual port. And this is just the name of the endpoint that I'm going to choose here. So this is one endpoint here, the index route. We're going to have a second one, and this second one will have the route price history, and it will take a parameter ZPID. This is why we do that. And what this is going to do is it's going to remove the button, show the loading animation. It's going to redirect the iframe, not the entire application, the iframe content to that endpoint. In this endpoint, what we're going to do with it is we're going to display a table containing the price information if it is existing. All right, so what else do we want to do? We want to say now that the color that we're going to use for this specific marker, remember, we're in a loop iterating over all the rows. All of this is done for every single data point. So we want to say that the color for this specific data point is going to be the result of calling our get marker color, passing here the row gross rental yields, and the row is of market. Again, if you have your own logic here with different parameters and different branches and so on, you just pass the stuff that your function needs and you will get a color depending on your logic. And now finally we're going to say folium.marker. We want to create a marker, and the location of this marker is obviously going to be the latitude and longitude of this row. And the pop-up information when you click on this shall be a folium.popup element containing a folium.iframe, and this should contain the pop-up text and should have a width of 300 and a height of 250. Again, you can adjust this if you want to. And then we want to have an icon. So how should this pop-up, how should this marker look? And we want to have here a folium.icon, and the color is the color that we get from our function, and the icon is a home item. Just because it's a property, you can of course also change this. And the prefix is equal to FA. I think this is because we have these specific FA icons. So this is why we need to specify this. And then we need to add this marker to our marker cluster. And this is basically it. So for every single data point, let's briefly repeat this. We drop all the NaN values. We make sure we have numbers here. We calculate 2 new features. We define how to get the marker color. We create a map centered at the mean location. We create an empty marker cluster, and then we go through all the individual rows of the data frame to extract some information, to format it properly, and then we create this pop-up. When you click on the button, this is what you're going to see. All the information just displayed here, and then also a link to the Zillow URL, a button that makes a call to another endpoint, that redirects to another endpoint, that shows a loading animation if we click it, and then we just add all of this together. And in the end, after this loop, so once we have all the data points covered, we say m.save, and we want to save this to templates/property map.html. So this is what we're checking for in the beginning. Remember, if it exists, just render it. Otherwise, the first time we're going to have to create it. And as I said, if you update the data frame, if you get a new CSV file after a month or something, then you want to also delete the HTML file, and the first time you will have to run this again. So return render template property map.html. And the larger your data set, the more time this will take. So this already takes quite some time here. I'm not sure, maybe a minute or something on my system with this 2 GB data set. If you have a larger one, it's going to take more time. But as I said, you only need to do it once, at least until you swap the data frame or the data set. So that is our map displaying, or this is how we create and display our map. The second part is the price history. For this, we're going to say app.route/price history and here we want to have now our int, which is the ZPID. So we're going to take the string from the URL, typecast it automatically into an integer, which the ZPID is, and we're going to also cache this function. The reason, again, we want to cache this function is because we want to make an API request, but if we made one already, then we don't need to do it again. We're not going to have a different price history necessarily 10 seconds afterwards. So we want to have a cache. If you want to get fancy, you can also implement your own temporal cache that expires after a day or something, but we're going to just go with a simple cache here. And I'm going to call this function price history, and it's going to take obviously the ZPID from the URL. And in here now, what we want to do is we want to basically do what the curl request here is doing, but we want to do it in Python. So we have this endpoint here, API bright data, datasets v3 trigger, and then the dataset ID, which is for the Zillow dataset. Of course, if you have a different application with a different dataset, it's going to be a different dataset ID. In the case of Zillow, it's this ID here. So we're going to model this in Python now. We're going to start by saying the URL that we want to get, the property URL that we want to get the price history for is equal to the data frame, where the data frame or the data frame row, where the data frame ID is equal to the ZP ID, which is passed here. From this, we want to get the URL values 0. So the first one. Now, of course, if you pass a ZP ID that does not exist, you're going to get a problem, but this should not happen. So the URL is just that. Then we also want to have the API URL. This one is also, again, something I'm going to copy, but you can also copy paste this just from the code here. So you just copy paste this here. I'm going to copy paste it from my code. And that is the thing that we're going to target. So we're going to define now the header, or the headers is going to be equal to the following. We're going to say authorization, and here now we need to use our API key. So we're going to use a formatted string Bera. So this is going to be a Bera token. Maybe we want to load the token actually before. So token is going to be equal to open the token file in reading mode and reading the content. Make sure you don't have any line breaks in here. You just have one single line with the content, and that's it, or with the API key, and that's it. And here now we're going to use that token. And the content type should be application/JSON. And what we're going to do now is we're going to say that the data that we want to pass here is just a list with a single entry, which is URL pointing to URL. Again, this is what we do here as well. They're basically, you can do this with multiple properties as well, but since we're clicking only at one property, on one property at a time, we just need a single URL, but that's the structure that you see here as well. So this is our data, and then we just have to say that the response is equal to requests.post. Now make sure you have requests, not request, because request is from Flask. We're using the package requests, not the Flask request. So post, and we want to post to the API URL with the headers that we defined, the JSON data which we created here. Now this response will give us a snapshot ID. This will not give us the data, this will not give us the price history. It gives us a snapshot ID, and we need to do a second request to actually download the data. So I'm going to say snapshot ID is equal to response.json. From this response, we're going to get a snapshot ID. And now this is why we need time. I would like to sleep for 5 seconds, because usually the snapshot is not available immediately. And instead of just trying immediately, we're going to wait for 5 seconds. And then we're going to make the next request, which is downloading the snapshot. For this, we have a different API. So we use this one here. And we download the snapshot ID that we specify here. So we're going to say API underscore URL is equal. Now I'm going to copy this again from my prepared code. And here now we have API brightdata.com/datasets v3 snapshot. And then here our snapshot ID. This is important. This is what we get from the response. And the format is equal to CSV. Then again, headers is going to be, actually let me copy this. Headers is going to be the same, but we don't need the content type JSON, because this is going to be a GET request. We just need to provide the token. And the response this time is going to be equal to requests dot get. So we're sending a get request to the API URL with the headers. And then we can get multiple responses. One response that we can get is snapshot is empty. This means there is no historic data. So if we get the message snapshot is empty, this is the literal string that's written there from Bright Data. If we get this string, it means that there is no historic data for this property. Another message we could get is snapshot is not ready yet, try again in 10 seconds. If we get this one, it means that it's not done with the loading yet. So either there is no data or there is data and it's being loaded, but we need to wait and try again. And the other way, or the other response we can get is data. So the actual CSV data. So we're going to say here, if snapshot is empty, exactly written like this, is in the response text, we're going to return no historic data. Otherwise, we can say then, while, I do this immediately as a while loop, I don't even use an if statement here, while snapshot is not ready yet, comma, try again in 10 seconds. Now it needs to be exactly like this. This is the exact message that we're waiting for. If that is in the response text, we're going to just say time sleep 10 seconds and try again. So basically copy this, do it again. And if it at some point says snapshot is empty, so basically I can copy this as well, then just do that. Because chances are it will say it's not ready yet, you need to try again, but then it's still going to be empty. So in this case, we still need to return no historic data. Otherwise, retry over and over and over again. And at some point, we're going to get hopefully some data. And then we're going to say with open temp CSV in writing mode sf fwrite response dot actually in writing bytes mode dot content, because dot content is a byte stream, so we need to write bytes response dot content. So this saves the CSV data into a file temp CSV. And now we're going to say price history data frame is equal to pd read CSV temp.csv. And then price history data frame is equal to price history data frame. And here we just want to have date and price. And then I say price history data frame date. I want to have this as pd to date time because this is a string usually. Price history. Why do I not get some auto completion here? Come on. Price history data frame. Date, so turn it into a date object, and then I want to actually turn it into a good representation. So I actually want to turn this into price history data frame dot, or price history data frame date dot dt dot string format time, and the format should be a basic year, so %y dash %m dash %d. M and D need to be lowercase, Y needs to be uppercase. And then finally we can return render template, and we need to return a price history HTML file, which we don't have yet. And we're going to pass to it the price history data frame as a parameter to process. All right. And the final thing, if name equals main, then we want to say app run debug equals true. Now, of course, if you deploy this, you're going to do this differently. I have a couple of videos on my channel on showing how to deploy an application properly, but that is now our code. The last thing missing here is we need a directory templates, and here we want to create a price history HTML file. We're going to keep this simple. It's not going to be complicated. Price history HTML file, and in this file we're going to import Bootstrap. Now I'm going to copy paste this here as well. Just use a content delivery network for Bootstrap like this. You can just type this if you want to, or you can just copy it from somewhere else. But basically stackpath.bootstrap.cdn.com, bootstrap 4.5.2, CSS, bootstrap min CSS. Depending on when you're watching this video in the future, there's a different version, so it doesn't make sense really to provide a specific line here, but just get bootstrap from somewhere. We don't really need a title for this. And then we're going to say in this HTML document here, we want to return a table. The table is going to have class, these are now bootstrap classes, table, table striped, and table hover. And it's going to contain a t-head, so a table header. The class of this one is going to be t-head-dark. And then we're going to have a table row element here. And we're going to say for column in price history data frame dot columns, and for we're going to have a table header field which is going to have the column, and then in the table body, so t body, we're going to say that we're going to display the data. How are we going to do that? We're going to say for row in price history df.values, and we're going to say and for, and here now we're going to say again table row, and we're going to say for cell in row we want to display a table data object td with the cell. So that's just basically what we're going to return to the pop-up. Now that is it. I think we wrote quite a bit of code. Actually, as I said, we don't need this, and we actually also don't need this. This is the whole thing. Now with that much code written, I'm sure I made a mistake, but the idea now is to run this application, and running this application will take some time. First of all, because we're going to have to load the data frame. This will take some time already. Second of all, we're going to have to, once we visit the index page, we're going to have to create the map. So this is going to also take quite some time. If we didn't make any mistakes, after it takes quite some time, it should also show us the result. Let's see if it crashes immediately. Otherwise, it's just going to take a lot of time here loading it. So you can see it's loading. Okay, I see a problem with the code, and obviously the problem is that I'm accessing here the whole features. Of course, this all needs to be a row and not data frame. So we need to replace all of these with row, because we don't want to have the full feature. We just want to have the field for this specific row. Now, did we do that somewhere else? I don't think so. So let us save this. And let's, actually, I don't think that we need to restart. Actually, let's restart the application. All right, so after quite a bit of loading time, you can see that we get the property map. You can also see that we now have in the templates directory this property map HTML file. And let's see if it works as expected. So I can zoom in. We should see different colors. This one is orange, for example, because it has, oh, actually this should be %. So I'm not going to change this now because I would have to rerun the whole script. But basically what you would want to do to fix that is you would want to change this here, the formatted, where is it? The formatted gross yield. You want to change this to just remove this and add a percentage sign in the end. I'm not going to do this now because otherwise I have to wait all over again. And maybe you also want to add a comma here as a separator, but that's not too important. You can see we have the information here. I also have the Zillow link that I can visit, and let's see now if the show price history works or if it crashes my application. Now either we're going to get nothing or we're going to get the table. So I hope we get a table to showcase the feature. Okay, we get a table, but it seems to be an empty table. No, actually we do get information here, but it doesn't show it. So why is that? Let me just double check this. So we get the data, we get the response content, and we write it to temp CSV. So let me see how this differs from my, maybe it's in the HTML file. Let's see, row in, oh yeah, okay, that's the problem. We need to say values, otherwise it doesn't work, but that shouldn't be too difficult. The only problem is now for this particular one, since I'm caching now, I'm not going to be able to do this. So if I just ask again, I'm going to get the same thing. But we can try somewhere else. So let's see a price history here. Chances are we're not going to get one here. But if we get one, we should also see the data. No, we don't get one here. Let's see if we find another property, maybe this one here, show price history. Usually the ones that are on market have a price history, not always, but oftentimes. There you go. So here we get now a table with the historical prices, or historic prices. Now I think these are mixed though, so I think that we have here rents mixed with property values, but yeah, this is also fine. And you can see that the coloring is depending on the yield. So here we have 6.39%, here we have 4.66%. And of course, if you want to change this to also include properties that are off market, because all of these here are off market, if we go to the Zillow page, you can see they're off market. But if you want to include them into the evaluation as well, you can also just change the coloring function. But this is how you can build a real estate scouting tool with Bright Data. Again, you can try to build this tool with a sample to get started. If you want to actually use this as a proper tool, you need to have some provider of data that you can trust, that you can get information from quickly, where you can get large volumes of up-to-date information and also real-time information and historic information. And Bright Data is perfect for that. This is how you can build this tool in Python. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, make sure to check out Bright Data, the sponsor of this video. You will find a link to them in the description down below. And other than that, thank you much for watching. See you in the next video, and bye.